Welcome to all. I am Monisha, Assistant Professor, Department of Mathematics, Rohini College of Engineering and Technology. Today I am going to teach the topic Euler and Hamiltonian Graph in discrete mathematics. So first I will explain the concept of Euler as well as Hamiltonian graph, and then we can move to the theorem. So a connected graph G is called an Euler graph if there is a closed trial or cycle, okay, which includes every edge of the graph, okay. Don't confuse Euler and Hamiltonian. Here the Euler first letter is E, okay. So you can remember Euler first letter is E and the edge first letter is E. So Euler means it depends upon the edge, okay. The definition is on the edge. Hamiltonian means the definition is based on the vertex, okay. Only one word is different. Euler means it depends on, the definition depends on the word edge, and Hamiltonian means the edge word depend upon the vertex. So you can remember Euler first letter E and the edge first letter E, okay. So Euler means it depends on edge. So Euler graph means it contains a cycle or closed trial which includes every edge of the graph, okay. Path means also the same concept only, but for Euler path means the starting and ending vertex may be different, okay. Closed trial means starting and ending vertex are same, okay. So here you can see an example of an Euler graph, okay. So it can start from A means it will move to A to B, then B to C, then C to D, then D to E, E to C, again C to A. So you started from A and you have N from A and you have covered all the edges exactly once, okay, that is important. Then there exists a closed trial, so such a graph is known as the Euler graph, okay. Next we can move to Hamiltonian, okay. So this is an example of Hamiltonian, and the definition is a connected graph G is called a Hamiltonian graph if there is a cycle which includes every vertex, okay. I told you no, only one word is different. Here every vertex of the graph exactly once, okay. So Euler means a cycle which includes every edges exactly once. Hamiltonian means a cycle which includes every vertex exactly once, okay. Or we can say a graph containing a Hamiltonian circuit or cycle is known as a Hamiltonian graph. But you want to know what is Hamiltonian circuit, okay. Hamiltonian circuit means it is nothing but a cycle which includes every vertex exactly once, okay. So here you see this is an example of a Hamiltonian graph. So you can start from any vertex, okay, your wish. So let us start from A. So if we move from A to B, C, D, E, F, again end with A means you see all the, which is a cycle, the starting and ending vertex are same and it travels through all the vertices exactly once, okay. So it is known as the Euler as well as Hamiltonian. This is an example for Euler also, okay, and Hamiltonian graph. So now it's an important theorem. Prove that in a graph G has more than two vertices of odd degree, then there can be a Euler path, okay. So if in a graph you are having more than, okay, not more than, so exactly 2 or less than 2, okay. Two vertices are having odd degree means surely in that graph you will have an Euler path, okay. Once again, if you are having a graph G and in that graph two vertices, okay, not more than means only two vertices are of odd degree means in that graph surely you will get a Euler path, okay. Proof. So let the odd degree vertices, okay, we have assumed that two vertices are having odd degree, and let us give the name. So the odd degree vertices be labeled as V and W in an arbitrary order, okay, anything, either first V or W next V, okay, that is not a matter. So anyway, two vertices, one is V and other is W, okay. So add an edge, okay. Now what I am going to do is I am going to add an edge, okay, one more new edge in a graph G between the pair of vertices V and W to form a new graph G dash. Originally my graph G have two vertices V and W with odd degree. Now I added one edge between the vertex V and W, so I will get a new graph that is G dash, okay. Since I have added one edge between V and W, already V and W have odd degree. Since I have added one more edge, what about the degree of V and W? It will become even, okay. So now the vertex, every vertex, okay, every vertex of G dash is of even degree. Okay, already we are having V and W as odd. By adding one more edge, it becomes even. So all the vertices of G dash is now of even degree. Okay, so all are even degree means obviously you will have a cycle or close or trial. Okay, trial or Eulerian trial means it is nothing but a closed trial. Okay, all are same only, closed trial. Okay, well, in G dash you are having an Eulerian trial, that is closed trial. So starting and ending vertex must be same. Okay, and let us give the name as T. Okay, then G dash has an Eulerian trial T. If the edge that we added to G is now removed, okay, now I am going to remove that edge. Okay, starting I have added the edge, now I am removing the edge. Okay, if I remove that edge means already I am having a closed trial T. Okay, if I remove that edge means what about that trial? It will become open. So one edge is removed means obviously it will become open. Okay, all the sides are closed. We see the example already. Okay, for the Hamiltonian and Euler cycle, if all letters are closed and if you remove one edge means obviously it will become open. So it will split into an open trial containing all edges of G, which is nothing but the Euler path. Okay, closed means it is Euler trial, open means it is Euler path. So obviously we will get a Euler path. This is nothing but the proof of our theorem. Okay, we got the proof. Hence the proof. Only one line, just we are assuming two vertices V and W with odd degree. First step 1, we are adding on one edge, so obviously we will get a Euler trial, that is nothing but a closed trial. Now again I am removing that edge means that closed will become open trial. That open trial is nothing but Euler path. Okay, so we got the Euler path. Thank you.